If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Please share it with all others who might benefit. Let's get started. So this video is in continuation to our sequence of videos on regular expressions. So far, we have discussed the theoretical aspects and we started some hands-on. In this video, we'll become a little more particular. So we will be looking for specific patterns within a data. Let's say you have an event log and you're interested in extracting the IP addresses. And what is the definition of a valid IP address versus just about any set of numbers. Likewise, we'll also be learning about extracting patterns. Let's say in a given data, you're only interested in collecting the contact information of the customers. So how do you go about extracting that? You might have noticed that while filling a few forms online, you get an alert that you've not entered a valid email address or a valid phone number. That's a kind of alert to inform you that you probably are making a typing mistake. Let's say you have a collection of numbers and you're interested in exploring this as a text string now. So what we're doing now is we are creating a doc string which has some numbers. And let's say we have already decided certain patterns that we are looking for. So first let's run this string and then we'll define the pattern. So what are we saying in this pattern? We've put a plus symbol and prior to that we put a backslash. Remember that plus symbol alone means one or more occurrences. But when we put a backslash, it means a literal plus. So we are looking for the occurrence of the plus symbol. And all these country codes, if you see, start with a plus, right? So we are saying a plus symbol followed by digits. It could be 1 or 2 digits, followed by a space character, which is backslash s, followed by 3 digits, hyphen 3 digits, hyphen 4 digits. These are the patterns that we are looking for. So we are looking for a plus symbol followed by 1 or 2 digits, with a space, then 3 digits, hyphen 3 digits, hyphen 4 digits. Some of these patterns comply to this format and some of these not. Let's see if we are able to filter the valid phone numbers. So now you see the first one that we got has a single digit with a plus. Then it has 3 digits, hyphen 3 digits, hyphen 4 digits. We got that. The second one has 2 digits with a plus symbol preceding it, has 3 digits, and has 4 digits with hyphens in between. This one, plus 25 again has plus followed by 2 digits. Then we have 3 digits, hyphen 3 digits, hyphen 4 digits. So this is again totally valid as a format. What did it exclude? It excluded this, plus 82. The first piece was fine. Space was fine. Then you had 3 digits, it was fine. Then you had hyphen and 3 digits. This was also fine. But you didn't have the last 4 digits. So this is considered an invalid number. Similarly, somebody might have entered the country code for US, which is valid, plus 1. Then the pattern is not appropriate. So we had to have 3 digits followed by a hyphen and then 3 digits and 4 digits. Here we seem to have got only 2 digits and that's why it's an invalid phone number. A lot of times when you enter a number, the system says that please enter a valid number. So these checks are there at the back end, which tell you that you probably are making a mistake, intentionally or unintentionally. Please note, we could have also used a grouping here. So we could have considered this as the first group, which is the plus followed by 1 or 2 digits, separated by a space, then 3 digits, then hyphen, then 3 digits, then hyphen, then 3 digits. So in some of the future examples, we'll also be discussing the importance of these groups. This again gives us the same output, as you can see. Now let's say we have some kind of a log, a system log, and you know cybersecurity is very, very important these days. You want to identify certain IP addresses which have placed a request or tried to connect with your network and things, and you want to figure out the specific patterns related to the IP addresses. So you know that IP address would typically be a digit. It could be anything from 1 to 3 digits, and it has these octets. These are called octets. You have digits from 1 to 3, followed by a dot, and then digits, then again digits, then again digits, right? So these could be, at all places, you could have 1 to 3 digits. So we have a pattern here that we are trying to look for, and this question mark followed by this colon essentially represents a non-capturing group, something that we don't want to use later. We're just searching as a pattern. So what we are saying is that we have digits from 1 to 3, followed by a dot. This dot, if we put in general without this cape sequence, it means that we are talking about any character except new line. We talked about it. So in order to see it as a proper dot, we'll have to put this backslash to read it literally like a dot as a pattern. And then we are saying we have 3 such repetitions. So you have a block of digits followed by a dot, which could be something like this, and then this. So we have this 3 times. And then finally we have a digit which could be anything from a single number to a number which has 3 digits. Like it could be 1, it could be 12, it could be 1, 2, 3. It could be anything like that. And then we have a word boundary. That's the kind of pattern that we are looking for. And then we are saying, let's find such IP addresses in the network log. So I'll have to run the previous line first and then this one. So when we run this line and then we run this line here, here is what we get. So it kind of traced all these patterns. But some of you who are aware of how IP addresses are designated, you must be aware that these digits here cannot be more than 255. But this seems to be capturing such patterns also which are invalid. 300 is not a valid octet. And then 168.1.500, this is again not acceptable. So if you want to put specific conditions while searching this log, what you can do is you can write a more comprehensive regular expression. Again, a non-capturing group which has values which could range from 250 to 255 or 200 to 249. So how do you read this? 250, then it could be anything from 0 to 5. So it could be 250 to 255 or 204, which means the second digit here could be anything from 0 to 4. So if it's 4, then we are talking about 240. And then if finally, it could be anything from 0 to 9 at the third digit. So if maximum value is 9, then it can go up to 249. And if we take the smallest values here, then it will be 200. So that will be 200. So this represents anything from 200 to 249. So far we have covered values from 200 to 255, but we have to have values from 0 to 199 as well. So this is the piece which covers values from 0 to 199. What it says is the first occurrence could be starting with a 0 or a 1, and that's with a question mark. Question mark means it's something which may or may not be there, either there or not there. Then we have single digits, which could be anything from 0 to 9, and we are talking about their 1 or 2 occurrences. So if you see, this particular piece would cover everything from 0 to 199. If this value is 1 and this value is 9, and we are allowing for up to 2 occurrences, then it could also be 199. And that's the same thing that we have repeated here. Could we make it more compact? Yes, we could have taken this as a group and we would have put a curly bracket 3 kind of a thing to see 3 repetitions of this. And the exact same thing that you saw here is something that's being repeated 4 times. That's where maybe putting this in one group and with a flower bracket 3 would bring 3 repetitions of this, and then we could have written it one more time and written it with a word boundary. That would have been easier. But let's say this is a more expanded form, and now the only difference in the output would be that you no longer will see this as a pattern. Why? Because we are allowing only digits up to 255. Let's run this. So see, that specific option which has 300 and 500 got eliminated. Again, you might find it initially a little difficult because it's something new, but overall when you're working on data and you have to really deal with messy data, you want to specifically focus on certain patterns with some information or logic, this comes very handy. It's all about practice.